Welcome to our video series, and we are looking at an RT Prac exam paper 1 for November 2024 for grade 11. So if you're a grade 11 RT student, this is the video for you. We've just done the other 3 questions. We're going to get into the last question, which will probably be on arrays. And if you've done the previous questions, you will have noticed that the theme is based on software for Santa. So we're doing software for Mr. Claus or Santa Claus. Just a reminder that in the video description, you'll find links to the data files. I strongly suggest that you go download the data files, give the question a try, and then come back to the video so you can see where you can improve. And there are links to individual questions, so you can jump to a particular question, as well as links to other videos for the other questions if you haven't done them yet. So let's get stuck into the final question, which is arrays. So here we've got a project. I've already got it open over here. If we go to the top, you'll notice that there are a couple of arrays already declared for us, and they mention that here in the question. There's an array children array, which contains the names of children. There's an array present array, which has the strings that represent the children's present, but they are parallel array, which means position 1 in the children's array will get present at position 1 in the present array. So they're all linked. So position 1's linked to position 1, position 5's linked to position 5, and so on. And the same goes for the addresses. Position 5 in the address array is linked to child at position 5 in the children array. So they're all linked. So they're all a bunch of strings. You can go look over here and see they're just strings. They all have a max of 30 records, and they are all linked. In other words, position 1 linked with position 1, which position 1. So this person is getting a teddy bear, and that's their address. Just so that you understand the context. The number of elements in these 3 arrays is not 30. There's a global variable called rnum. That tells me how many values, because it might not be full. It looks like this array has some gaps at the end. So we don't want to go to the end of the array. We want to go to the end of the values, which is the rnum value. Question 4.1, let's go look there. I don't know if that's where it starts. Let's start with that. So write a procedure called display array. It doesn't take anything in, but it's a procedure that displays all the values in the parallel arrays like that. So we're going to put the name of the child from there. We then in brackets are going to put the address of the child. Then we're going to have a tab and then the present. So that's what our procedure is going to do. So I come here, we're going to declare a procedure called display array. It doesn't take anything in, so we can leave it just like that, Control-Shift-C, and we can write the code. So we're going to do a for loop that goes from 1 until the number of elements in the array. I don't know if there's 30 in there. I don't know if it's full, but I know there's rnum. That tells me how many values are exactly in the array with regard to how many values are filled. And we are going to, in the rich display.lines.add, we are going to display the name of the child first. Let's just get that done first. We're going to display array children position R. We're just going to test it. And then they say add code to the button Q41 that calls this procedure. That's when we click on that button there. We're going to call the display array procedure. Now I'm not finished. I've just made it display the one array. So position 1 of array children, then goes position 2 and position 3 until the end of the array. So let's just see if that's working. When I click on that, there we go. All the names of the children. Then we're going to, after we've done the children's name, we're going to add a bracket. I think we should have a space and then a bracket. It's a space, then a bracket, looks like. So let's do that rather. Let's put a space there. And then we're going to put in the value of the address at position R. And then we're going to close the bracket. So we're going to put the name of the child, then have an open bracket, the name of the address, and then close bracket. Let's just try that to see what that looks like. There we go. That looks nice. And then we're going to have a tab after that. So plus #9. And then we're going to have the value in the present array. So at position 1 of the child, position 1 of the address, position 1 of the present. Then position 2 of the child, position 2 of the address, position 2 of the. So that means we are getting all the displays done. There we go. That looks perfect. We wrote a procedure that does it. And then we just called the procedure over here. I've got a funny feeling we're going to call that procedure again. But let's just see how it goes. So there we go. There's the 7 marks. Done. 4.2. Write code that prompts the user for the name of an address. Let's see if it's done it for us. Let's double click on there. Oh, it's done. There we go. It's got the name of the address. That's great. I don't need to do that. Complete the code that displays all the names of the children who live on that street. So here they're giving just the name of the street, but that name isn't exactly in the address. It's part of the address. We're going to go and loop. We're going to loop through every value in the array from 1 until how many values are in the array? It's rnum. Remember, it's not 30. We don't know how many are in. We know how many spaces are available, but we don't know how many values are actually in. So we're going to do that. if S Street is the same as array address at position R. If Elm Street is the same as the address. Now that's not going to work because none of these are Elm Street. It's something Elm Street. So we actually got to see if it's somewhere. We can like delete it. We can find if its position is some. So we actually want to find if the position of the street that we're looking for is inside of the address. How do we know if it's there? Well, the position of the street will be a 1 or a 2 or a 3. If it's not there, it'll be a 0. So as long as it's not a 0, as long as it's greater than 0, we know that that street is inside of that address. And if that's the case, then we can display the name of the child. What do we want to display? We want to display the name of the children. So we're going to display the children's name. So rich display lines.add, and we display the array children's name at that position that we found a match. So if we find a match at position or an array at position 3, then display the third child. Let's just test to see that works. Elm Street. We've got the right 2 names. That's great. But they also want us to, code must also display how many children live in that tree. So we're going to count them. Every time we find one, we must count them. So we're going to make a Dracula variable. So let's make a Dracula, I count Dracula, and we are counting them. So we must remember, you must always initialize our count to a 0. And every time we find a child, not only do we display its name, but we're going to increase it by 1. Because we found one. We found a child that lives in that street. There we go. And then after the loop is done, after that's all been done, then we can say rich display lines.add, and we are displaying our count. Now just a couple of things to take note of here. First of all, if you look at the display, it has a bit of a gap between. So I'm actually going to go here. Let's try putting in a hash 13 because that's a new line, and then our count, but we want to convert our count from an int to a string so that it fits. So let's try that. Elm Street, there we go. We've got that, and we've got 2, but I don't think we actually want 2. We want to say number of children in Elm Street is 2. Actually, we're very close. We're very close. We're just going to put in that text, number of children in Elm Street. So we're going to say plus number of children in Elm Street. Now, where do we get Elm Street from? We get it from the street that they typed in. Put in at, and then we put in an equal to sign after it. So then after that, we're going to put an equal to sign. That should work. Let's try it. Elm Street, there we go. Number of children in Elm Street equals 2. Perfect. So that's a simple count algorithm. Go through all the records. When we find what we're looking for, we count it. In this case, we're not finding for an exact match to the street. We find if the street is somewhere inside the address. Let's move on to 4.3. Complete the code that prompts the user for the name of a child. That's been done for us. There we go. So if I come over here, 4.3, we've got the name of the child. And now what do we want to do? Then search for that child's name in the array and change their present in the corresponding position in the present array. So when we find that child's name, we must change their present to a new gift based on this radio group. Let's first see if we can find the child and just change their present to X and see if that works. So this is a simple search algorithm. We're searching for a specific child, and that we need to indicate if the child's name was not found. So this is our search for algorithm, which means we're not going to use a for loop. We're going to use a while loop. So we're going to have our looping variable for our while loop, and I'm going to have my thin ghost, my boolean variable, to tell me if I found it or not. Okay, so let's just do the search part right. Let's get that part. We're going to assume that we haven't found it yet, and we're going to set our boolean value to false and our looping variable to 0. While we have not reached the end of the array, which is inum. While I has not reached inum, we must look for the child. If we find the child, if array children at position R, yeah, so before we do that, we're not going to look at position. Before this, we're going to actually increase R, so it becomes a 1. Increase R becomes 1. If the position 1, that child has the same name as the name, then we have found what we are looking for. And if we found what we're looking for, we're going to say be found equals to true. And I'm going to say the present of this child at position R. I'm just going to set it to X, just so we can see that it works. When we find it, we want to stop. So that means if it's at the end and while be found is equal to false. While we haven't found it, keep looking. So both of those options must happen. So while we haven't reached the end of the array and while we are still looking for it, keep looking. The moment we find it, the moment it's true, that won't be true, which means we can stop the loop. The moment we reach the end, that won't be true. We can stop looking. And that means that if we get here and be found is still false, that means it went through this entire loop and it never did this, which means it never did that. Which means we can say show message s name not found in array. Okay, so I don't know if they gave me a particular message that we must display. Just display a suitable message, so that's fine. So maybe they're not on Santa's list then, if that's the name we're looking for. So let's just test that. If we run it, we can display all the children. We can see all the presents. Let's go allocate new presents. We've got Zara. Let's go OK. It looks like they found it. If I display all the, you see Zara has changed to XXX. If I did the same to that other child, I think it's spelled like that, and display, boom, not Mia, but there, you can see that one's also changed. And if I type in Mr. Long, because we know Mr. Long's not on Santa's list, Mr. Long not found in the array. Okay, so just fix that message. But yeah, so that's working. Fantastic. What is the present that they want? So let's look at this. So a global array called array list contains the names of 12 different presents that has been declared and populated for you. The first 4 elements in the array are educational. So 1, 2, 3, 4 are educational presents. The next 4 are action figures. 6, 8. I think teddy bear is technically an action figure or doll. There we go. So that's doll. That's fine. And the last 4 are vehicle presents. So those are vehicle presents. Okay, that's fantastic. The present's name must be changed to a random present from the list based on what they select via the radio group. So, okay, if they come here and they selected educational present, that means we must go and get an educational present, a random one, but only from the first 4 blocks. And if they want an action figure or doll, we must only get from the next 4 blocks and so on. Okay, so that makes it interesting. So that means our random number that we choose, we're going to pick a random number from 1 to 12, but actually not 1 to 12. If it's educational, it's from 1 to 4. If it's a doll or action figure, it's from 5 to 8. And if it's a fire truck or a vehicle that they want, it's from 9 to 12. Okay, so the present is dependent on what they select in the radio group. So we can do that first. So that's radio group present type. So before we do this, let's get the present type. So that's how do we know which one they select? If the radio group, which one? The present type. Well, how do we know which one selected? The item index. If that equals a 0, that means that they have a present for educational. That means they want an educational present. That means I need a random number. Random. So I'm going to generate a random number. Equals to random. Now, how do I generate a random number? I can use the random range. And random range says we start at position 1 and we go until position 4. Did you say 4? No, that's wrong. Because remember, random range goes from 1 until 1 before that. So that means you would never get a puzzle set if you use that. We want to include puzzle sets. So we actually need to go from 1 until 5. Because remember, random range goes from 1 until 1 before. Now, random range only works if we have math at the top, which we do. Fantastic. So that helps me with that. Okay, so I've got random range. I've got that random range of the present, so 1 to 4. So then I can say present. I'm going to give it a present. S new, the new gift. S new will be whatever is in the array list, because that's the array with all of these presents. And we're going to use at position R random. Why? Because R random is going to be a random number from 1 to 4. And they selected an educational gift. Else, and we can literally copy and paste this. If it's a 1, then the random gift must be a 5, a 6, a 7, or 8. So we want to start at 5, and we want to go until, did you say 8? No, it's till 9, because remember it's 1 before that number. So we want to go from 1 before the 9. So get a random number from 5, and that becomes the new one. Else, and we can literally copy and paste this one more time. And now if it's the other option, which we don't even have to check if it's option 2, because if it's not 0 and 1, it must be option 2. If it's this, then the random number is starting at position 9 until position, we don't want to select a block that doesn't exist, until 12. So did you put in 12? No, it's 13. It's still 1 before that number. So make sure that you get your random numbers correct. So 1 before that. So there we go. That's correct. There we go. And so we've got our random. We could have actually done this part outside of it. So just generate the random numbers, then over here do it once. That works fine. So now when we allocate the random present, we are just going to allocate S new, whichever this new present is that we've allocated. I think that's all right. I think it's all done. Just take note, a suitable message must be displayed once the present has been changed. And then the display array procedure must be called. So if the array present has been changed, then we must do the following. We must display show message updated, whatever the message is that we want to say. Displaying a feedback message, and then we're going to display array. Call that display array procedure so that it will display all the values again. So let's try that again. So let's do that. So we're going to allocate new present. Zara, we want an educational one, updated. I should probably spell that correctly. But Zara, if we look there, has a chess set, which is one of the edges. If we give her a figure and a doll, to the Zara again, you'll notice that she's now got a teddy bear, and I'll give her a vehicle. It's now given her a toy train. If I do it again, it's a different toy. That's a vehicle. Okay, so it is working. I should probably change this updated to updated, not updated. There we go. I think that's all that they want. They don't give me any other diagrams. I think that's all correct. It's done. That's a search example. Fantastic. Now, let's go to the last one. 4.4. Nearly there, grade 11s. Complete the code that displays the names of the children that are siblings. Children are considered siblings if they live at the same address. You can assume that no house has more than 2 siblings. Okay, so that's interesting. Display the name of the children and addresses in the rich. So we can say the name of the child and the child live together at that address. And they give us a hint. If the array is sorted based on the address, then all the siblings will be adjacent next to each other. So because they give me that hint, I'm assuming we need to sort this array based on the address. And we're actually not worried about the actual present, we're worried about the name. So that's the key thing with parallel arrays. If I sort the addresses, if I swap those two to be in a different order, I need to make sure I swap those two names as well, so that it keeps it consistent. So that if I move 15 Maple Street to position 2, then that name must also move to position 2 to keep it consistent. And technically the same for the present, but I don't think we have to do that. This question has nothing to do with present, but we'll do it anyway. Okay, so we'll go here and we'll do a sort first. So to do a sort, we need to do, I'm going to do a selection sort. We're going to have 2 variables. I'll type integer, and I need a temp variable. And I'm going to make a temp variable type string. So now to do a sort, the first part of the sort. So I'm going to write the algorithm for a selection sort. There we go, do that so long. So there we go, there's the sort algorithm. We go from 1 till 1 before the end of the array, and then the second loop goes from 1 after the first array. That's not a 1, that's a r plus 1 until the end of the array. If the first loop 1 is greater than the second loop, they don't actually mention if it must be descending or ascending. It doesn't make a difference. Let's just keep it to ascending. Then we swap the addresses. We put r into temp, or the value at position I into temp for the address. And then we change r. We've got it recorded there, but we can change r now to j. And then j changes to what r was originally. That's the swap. But remember, whenever we swap the addresses, we must do the same thing. So you can literally copy and paste this for the children's names. So we're going to swap now the children's positions, because it's a parallel array. If we change 1 and 3, we need to change the children at position 1 and 3. So I'm just going to change the name of this array to array children, and technically we have to do it again for the present as well, because the present's also part of it, but I don't think it'll make a difference in this case. But array present, so we can then say swap the array present. So if we do any changes to the array, sorting it, it'll at least keep the children and the presents consistent. So it's addresses, and so the moment we find the addresses in the wrong order, swap the addresses, swap the children, swap the presents, so that they're all the same, and that will sort our array. So let's just test that, and I'm actually going to type in display array now so I can see what it looks like. Let's have a look. We can see it's not sorted according to address. The addresses are all scattered, but if I do this, do you notice how it's sorted? And there we can see all of the siblings are next to each other. Okay, so now that we've got that part done, that's most of the marks, I think. Now we can loop through the array again, because now it's sorted. We're going to loop from 1 until how many values are in the array? Num. And what are we going to do? We're going to check that the 2 values are the same. Do you remember what they said there? If the 2 values are the same, if the address is equal to the address of the next one, that's how you know they are siblings. So look how we do this. If the address at position R, because that's what we're looking at, is the same as the address at position R plus 1, the very next address, then we have siblings. If this is true, then we can display in the rich edit. What are we displaying? We need to display the name of the one child and the name of the other. Let's just do that part for now. Display the name of the child at position R plus the text and then we're going to put the name of the child that's coming next, which is R plus 1. And they're both strings, so that should work. So it's array display dot lines dot add. Don't forget that. There we go. So let's just test that. Okay, we don't want to display the array anymore. Let's take that part out. There we go. I think we've got the exact names. They've got the exact names. I think they're perfect. There we go. So we just got to add now live together at and the address, which it doesn't matter which address we use. They're both the same. So that's technically correct. So we're going to come here, and after the name of the second child, we're going to put a plus and put more text, and that text is going to be the text live together at the address at position R. I think we've got a space there. There we go. So let's try that. There we go. Did we get the same results? 100% the same. Technically, just so you know, technically, this should go for R-num minus 1. Do you know why? Think about it. Why is that technically the better option? Because if we are looping from 1 till R-num, then when we check R-num, we're going to be checking R-num plus 1, which is going to be nothing. If this array gets full, this will cause a crash if we don't have that minus 1. So that's why it's good to go to 1 till the second last one. Because if you're checking the second last one, you're checking the second last one with the last one. You can't check the last one with the one after the last one. It doesn't exist. So luckily this array isn't full, so it works. But if this array was full, if we didn't have that, the array would crash. So make sure that you have 1, 2, R-num minus 1. Whenever you check in a value with what's coming next, you don't need to go to the end. You just need to go to 1 before the end. There we go. I think that is done. I think that's all correct. Well done. That is all the questions done. Well done, grade 11s. Hopefully you've enjoyed this paper. Just go make sure that you go check out our playlist. We have other exam papers that you can use to practice if you need more practice. And good luck for exams. If you haven't clicked that subscribe button, then what are you waiting for? Support the channel. Support at Mr. Long IT and Cat, as well as our computer terms channel at Mr. Long Computer Terms, as well as on TikTok at Mr. Long Education. And help us to help you. And remember, don't do it the long way. Do it the Mr. Long way.